but the causes are still there. The causes of that decline are still there, and as far as we know, the population is probably having a hard time. Criterion A3 is future decline. This is where you're, based on the information you have today, you're projecting the likelihood of the population declining at a particular rate within the next 10 years or 2 generations, up to a maximum of 100 years in the future. And then criterion A4, this is a little bit difficult to explain. We call this the shifting time window. This is where we're looking at a period of 10 years or 3 generations in total. But you have some data for part of that time period. So you may have data from, say, 5 years ago, but nothing from beyond that. But you do have very good information about the causes of decline, the threats in place, and information about the likelihood of those threats carrying on. So you can actually construct a population decline model. Remember in the data quality assessment, the presentation that I showed you a few minutes ago, I showed the example where you had the 4 survey sites, you had some data in the past, and you knew the habitat was shrinking, so you could project what was happening in the future. That's the sort of thing I'm talking about here, where your assessment is somewhere in the middle of that decline curve. But you've got some data in the past, and you're projecting the rest of that 10-year, 3-generation time period into the future. So you may have data from 1 year ago and project 9 years into the future, or you may have information from 2 generations ago and project 1 generation into the future, or 1 generation ago and project 2 generations into the future. So that's why it's called a shifting time window. I see some glazed books. Hopefully it will become a bit more obvious. The summary sheet actually goes into a bit more detail here. The actual definition is included here. So on the summary sheet, at the top part of that, you have the criterion A1 thresholds along the top. These are a bit higher than the thresholds for A2, A3 and A4. So although we developed criterion A1 to accommodate fisheries management, and it also applies to forestry management as well and other management practices. We did increase the thresholds before somebody can actually use this criterion. The other details of criterion A1 appear in the text below. And then for A2, A3 and A4, the thresholds are given here as highlighted, and the details appear down below. And for all cases, A1, A2, A3 and A4, whichever percentage reduction you are stating, you should also state what that is based on. Is that based on direct observation? Now, in this case, IUCN has this terrible habit of using terms which just cross over each other all the time. So before I was talking about data quality being observed, where you look at every individual in the population, that would refer to the rate of decline that you are actually you've actually seen by counting every individual. But you can actually, sorry Rebecca, this is going to go on a bit. You can actually estimate a rate of decline of, say, I've estimated 60% decline in the past for this species. So you're assessing it as endangered under criterion A2 or A1. But you're estimating that because of samples that you've taken, and you've then assumed that what's happening in those samples is also happening elsewhere in the range. But part of the information you've used is observations of, in general, you've actually repeatedly gone out to do the surveys, and you've also, as well as seeing the declines in your sample sites, you've seen a general overall deterioration in the population, just overall, just by walking through the area over different time periods, or by interviewing local people who observe these species in the wild every day of their lives, and they're getting reports saying, yeah, I've seen there used to be thousands of these, and now there's only hundreds of them, or dozens. So that would be observed information. But the actual measure was estimated because the actual measure, the data themselves, came from scientific surveys. Does that help to explain the difference between those two terms? It's really awkward that IUCN chose similar terms here. Okay, well, there's no questions at the moment. You may be using an index of abundance, so trade estimates or catch per unit effort or some other sort of modelling exercise that we use to calculate the rate of reduction. You may be using the general decline of the range area, shrinkage in the range, or deterioration in habitat to infer or suspect your rate of reduction. Or it may be based on exploitation levels of the species. Or it may be based on any of these other factors, so pollutants, pathogens, viruses, diseases, introduced species. You can use one or any combination of these as the basis of your rate of reduction. I've left the two examples in here, so these are very, very general examples. So we have an example of a whale, where after all of the gathering of the data, compelling data, we have a generation length estimated at 31 years. The population decline is 70 to 90% over the past 3 generations, based on all the calculations that we've done. But now the populations appear to be recovering. The causes of those declines have been commercial whaling. It's been fully understood, it's very clear that the commercial whaling has caused these declines, but measures have been put in place to stop the whaling practices in the past 10, 20 years. And now the population decline is being reversed. The population is starting to recover, it's actually improving now. Nevertheless, that long generation length means that still within the last 3 generations, within the last 93 years, there has been this massive decline. But it's showing recovery. However, if the commercial whaling did begin again, then the population would decline further, and it would be more of a struggle to get back up to that level again. So with all of this information, you can assess the species as critically endangered, stroke endangered. Oh right, because it's 70 to 90%. It's at least 70% reduction, so it's at least endangered because it meets a reduction of at least 70% over the last 3 generations. If it was at least 90% over the last 3 generations, then it would be critically endangered. The percentage decline is based on sightings, observations of the species in the wild. It's been based on monitoring surveys, it's been based on scientific reports, it's been based on statistics and records gathered over time. So we're using sub-criteria A1A in this case, and A1B because of the monitoring, the index of abundance, and D because of the exploitation. That's what caused the actual decline rates. So because there's a bit of uncertainty here, we have this range of 70 to 90% reduction. It would be up to the assessor to decide, is the figure actually 70% or is it 90% or is it somewhere in between those two? So does it still meet that critically endangered category, or does it meet that endangered category instead? I didn't actually go into uncertainty earlier on, but uncertainty, if you have a wide range of figures in your data, and you're not sure which end of the scale to go to, you then do have a degree of subjectivity in your final assessment, that you have to justify that. You have to justify, well, I'm going for the higher category because, in actual fact, declines within the last 3 generations have mostly been at that end of the scale. It's just that recent data we're not quite sure if it's verified enough to actually say the decline is actually now estimated at a lower rate. So it depends on the situation. There is a certain degree of subjectivity in that situation. But the Regulus criteria do allow for uncertainty and sort of fuzzy logic in the assessments. And we do have tools available to incorporate fuzzy logic into your assessments. There's tools such as, you can go to the Regulus website to see all of these tools. There's things like Bramah's Regulus, which is a piece of software which you can use to do your assessments, and it brings in uncertainty, your attitude towards uncertainty. You can set the system as to how precautionary you are or how evidential you are, and it builds in fuzzy logic to come up with the best estimate of the appropriate category for your species. We have a similar situation in our own database, the Species Information Service. We have a sort of fuzzy logic system in there where you can actually put a range of figures in, and the system takes into account that there is a range of figures in that data field. Okay, so, as I said before, it's not an exact science. So in this case, we've assessed it as endangered, because they've got that quite wide range.
In this method, the problem is already identified and stopped in whaling.
Yeah.
So what about, for instance, as amphibians that have been produced and you don't know why, and then after like 20 years survey, it seems like they recover and they know that it is there, the disease. So they recover, but the disease is there. So it is considered as stopped or unquote.
In that case, you would use criterion A2 because the cause, although the population has shown it, so you've got an overall decline rate, but the population has shown some kind of recovery, because the initial cause of the decline or the potential cause of more decline is still there, or even if it's recently been brought in, it's a potential factor. Well, with amphibians, it's a very real factor. It's likely to cause a decline in the future as well. We would use criterion A2 because it's not that species is not safe. A1 would only be used where you have a very clear-cut case where this caused that decline, this has now stopped, that population is now recovering, there's nothing else in place which is going to affect that species at the moment. So you would use A1 in that case. And then over time, as it recovers, it would slide down the threatened categories and eventually become least concern, ideally. So, but if there are real threats in place which are going to cause more declines, or likely to, use A2. And if you're projecting into the future, use A3. You could use a combination of both, use A2 and A3. Do you want me to go through a second example, or do you want to go into? So, here we have a plant. I don't think any of you are botanists, are you? Any botanists? Okay. Which is great, because the example we've got is a plant which is fine, because we want you to get used to the criteria and not argue about the species, which is great. So, we've got a tree. The generation for this particular species is not actually known, but for similar species it's kind of about 50 years. So in this example we've used a different species to infer that the generation length for this species is probably similar. That's quite a common thing to do, and it's perfectly acceptable. You don't always need to have that specific biological research on that specific species. If you've got similar species with more information, we can use that. But again, be clear in the assessment, make that known to us. In this case, the species is endemic to dry forest, which has been intensively cut for agriculture over the last 100 years. Today it occurs only in highly fragmented forest patches, and the species suffers from browsing from deer and cattle, and uncontrolled fires sweeping through the region. based on all of the evidence, the assessors have estimated a 95% habitat loss over the past 150 years, so that's 3 generations, at least 3 generations, given population densities and distribution and suspected population decline of at least 50%. So in general, the forest area has been 95% decline. This tree will make up some of that habitat, so it makes up some of its own habitat basically. But for this particular species, given that 95% habitat loss, they suspect that the population decline is about 50%, or at least 50%. So in this case, we're assessing the species as endangered under criterion A2. Now the reason for this is because the threats are continuing. They haven't stopped. There's no control of the fires. There's no control of the browsing from the livestock. Habitat loss is ongoing. Regeneration of this species is close to 0 because of the intensive grazing. Seeds are also consumed by butterfly larvae. Suspected population decline of up to 80% over the next 100 years. So in this case, there's enough information for the assessors to make a population decline model projected into the future on the assumption that these threats carry on as they are at the same intensity that they are at the moment. So they've got this, somewhere they'll have a population model. And from that model they have estimated or suspected that there's an 80% decline in the next 100 years. And that's based on massive habitat loss, introduced predators. So for this example, we're using category endangered, using criteria A2 and A3. So you can use a combination of the sub-criteria. The only one you cannot use in combination with the others is A1. If you're using criteria A1, you are saying the cause of decline has stopped. So you can also say A2, which says the cause of decline has continued, or A3, which says there will be decline in the future, or A4, which says it's continuing, basically. So A1 is the only one you have to use on its own. Okay. Oh, I thought I'd take this out from the near threatened example. Okay, a word on near threatened. I've said before that near threatened sits just outside the threatened categories. When we're referring to criterion A, this means that the species would sit just outside of the reduction threshold for vulnerable, basically. So you might have data to, let's see, in this example, you may have data to say the population has declined by 40% in the last 3 generations, but the decline has stopped and the causes of decline are understood. I'm not sure, why is this, it's not my example, sorry. Why is this near threatened? Population has declined by 40% in the last 3 generations, that is more than 30%. It would be vulnerable in that case. Sorry to put Rebecca on the spot there. This may have been an example that we've done with today, I think. Right, actually I think this is wrong, because if it's declined by 40%, then it's more than 30%, so it should be vulnerable under criteria A1. If the population had declined by, say, 20% or 25%, then it would be near threatened on the basis that it almost meets.
No, this is A1.
Oh, it's A1? Sorry, higher threshold. It's me that's wrong. I need more sleep. Okay, sorry. Criterion A1 then. Yes, because it's not more than 50%. Because it's 40% decline, then it doesn't quite meet that threshold, so it would sit in your trend. If you were basing this on A2, then it would have to be less than 30% decline to meet criterion vulnerable A1, A2. I clearly need coffee.
I would suggest we just
I think we do need to move ahead. So the second example here is actually referring to criterion A2. So if it declined by 20 to 25%, then you can put it into your trend because it's just outside. Okay, let's break into the working groups. I say I've laid out 3 tables, up to you if you want to break into pairs or 2 groups of 3. There's one here, one there, and one at the back. On these tables you will find, well, I've actually only put out 2 case studies, but I can bring more. There's one case study that you will read, it's a plant. Just read through all of the information in the document. It's only 2 pages, it's not very long. And then go through the summary sheet for the thresholds on the criterion A. I've also put a criteria booklet there, and you'll find user guidelines there. I've got my copy of the user guidelines there, and